as Michael kind of anticipated, we will now speak about some important drivers in the modeling. So let's start with the load. And some of you might know this, but given that it's a Microgrid 101 course, I think it's good to set this as a reminder. So what is the load? It's the demand, which can be electric, cooling, heating, that needs to be fulfilled. And this can be done either by importing electricity from the utility or by generating it on site. And it's important not only to look at the annual or monthly demand numbers, but we must also look at the load shape. This is key for cost, for efficiency, for resiliency. The appropriate load management helps reduce peak demand, cut operational cost, enhance overall resiliency, and improve the system performance. So it's key to pay attention to the load shape. The thing is, we don't always have the 8760 to know what that load shape looks like. And that's why Xendee offers different tools to help with that. One is we have a load profile database that has different load shapes based on different building types. We also have the load builder, which basically allows you to take those load profiles and edit them accordingly and then scale them to match your specific load. We also have an integration with OpenEI, which allows you to choose based on the climate zone, building type, age of the building, and it will automatically bring these curves for each month of the year. And finally, if you have a user with utility API, we also have an integration with them, so you can pull in that information directly from the API. Up next are tariffs, which are also a key component. So here I'll do kind of like an overview, and then we'll see how each promotes the adoption of DRs. So flat rate's pretty straightforward. It's a constant rate regardless of the usage or amount. Time of use, here rates actually vary based on the time of the day, and prices are higher during peak demand and lower during off-peak. Tier rate, basically, the rate changes once the usage exceeds a certain threshold. Demand charges, another component that adds costs, and it's basically based on the highest power demand in a certain month or period. Real-time pricing, similar to time of use, rates vary, but in this case, it's based on actual market costs. And finally, net metering, which we'll see in a bit more detail, it accounts for the rate at which you can sell excess energy back to the grid. So let's see how each one of these impact the adoption of microgrids. So flat rate, there isn't that much of a financial incentive to shift it to DRs because flats are rate over the whole day. But when it comes to time of use, there is an encouragement here for load shifting and energy storage solutions such as batteries, which make microgrids more valuable. Similarly, in tiered rates, the adoption of microgrids can help reduce the overall consumption so that you stay in the lower cost tiers. Demand charges, once again, microgrids can help reduce those peak demands and manage consumption. Real-time periods, similar as time of use, microgrids can help mitigate the risk of those high market prices by providing this alternative energy source. And well, net metering, of course, it encourages the generation on site because you can then sell that back to the grid. And going into a little bit more detail regarding them, as I mentioned earlier, it allows you to generate your own electricity and offset your consumption by sending that excess energy back to the grid. And that energy that is sent back is, you actually receive some credits on your utility bill for that help you reduce the overall cost of energy. This is interesting because you're still connected to the grid, so you still have like a reliable energy supply in case your generation on site is insufficient, but you do have your DRs and you can generate excess energy at some times of the day, which you can then sell back. So that kind of covers the incentives. And now moving on to financing options, it's important to kind of understand the pros and cons of each financing method before kind of starting modeling. So Xendee Design offers 3 different types. upfront cash purchase, loan purchase, and amortized cost. So in the first case, pros here, there's no interest rate or any additional fees, and it simplifies accounting because it's a single purchase made outright. Cons, it requires significant cash, and like that might impact your liquidity and your ability to purchase other investments. The other one here is that it doesn't offer a fair comparison between DRs with different lifetimes. So this is also a con of loan purchase. What basically happens here is, let's say you have a project that's, the project lifetime is 10 years, and you're considering battery that's 15 years and a generator that's 30 years. Then the comparison isn't fair because you are only considering the lifetime of the project, and you're not considering that residual value of those technologies if they are kind of like longer than the project or different between them. So that's upfront cash purchase. Loan purchase, pros here, it allows you to acquire assets without immediate cash outlay. And it also allows you to spread those costs over time. The cons here, it involves interest payments, and it also adds debt to your ship. And same as with upfront cash purchase, it doesn't offer a fair comparison between DRs with different lifetimes. Finally, we have amortized cost, which reduces that immediate financial burden, and it allows you to spread costs over the asset useful life. Doing this, it provides the fair comparison between DRs with different lifetimes. Cons here, it doesn't offer a detailed modeling of financial instruments, and there's no concept of project lifetime because you're focusing more on the asset's lifetime. So that's about financing options. Up next, I have some examples of incentive programs, but we'll cover these during our demo, so I'll skip these for now and focus more on CHP so that we can dive right into Xendee. So Michael kind of mentioned some of the advantages of combined heat and power. It's basically pretty efficient compared to separate heat and power generator because it simultaneously produces electricity and thermal energy from a single or multiple fuel sources. It basically reduces energy costs because it's pretty efficient, and it utilizes the waste heat from heating, cooling, or other industrial processes. We will see this in more detail once we go into the modeling. Both projects that we'll see today work with CHPs. It also helps lower the greenhouse gas operation due to what we mentioned about it being highly efficient. And it, of course, enhances reliability and resiliency, which is crucial for critical facilities. Today, we will be working with a hospital and an airport. So in both cases, this is pretty important. So before we kind of jump into Xendee, I wanted to give you an overview of the products that we offer, and this has to do with what Michael previously described, because we basically have these products that accompany you through the whole process. So from the discovery phase into the proposal, all the way into the detailed engineering design, and even the operation of the site. So let's say you have several sites that you're looking to decarbonize, and you need to know where to start. Then you can use our Discover tool, which basically takes the addresses of those places, some information regarding the load and the technologies, and provides a rank ordered list based on ROI, CO2, or other variables you might want to consider to help you see where to get started. Then, once the sites are selected, you might need to run feasibility studies, and maybe you don't want to spend as much time or resources before any work actually gets contracted. And that's where you can use Propose, and we will demo Propose now. But it's basically a catalog-driven tool which allows you to very quickly and accurately create feasibility studies that you can then share with prospects. Once you decide on that site, you're gonna go into some more detail, maybe model an outage, maybe work with multi-year, or work with time series and 15-minute interval data. Then design is your tool. We'll also demo design today, and Rita will go step by step with it with you, so you'll get a chance to model in design as well. And finally, once the site is operational, you might want to continue to work with the same technology as you did before, and that's when Operate comes in place. It basically uses the same algorithms as the other tools, but incorporates real-time data to ensure that the runtime of the operation is constantly being optimized. This was covered in some of the examples that Michael shared with us right now. So without further ado, I'll stop sharing my presentation and we'll dive right into Xendee. Great. So you should have your credentials to be able to log in, but don't worry about it right now because you'll do that with Rita. For now, just try to follow along. But basically, once you log in, you'll see something like this. If you go to projects, in this case, we'll create a new project in Propose. So new Propose project. In this case, I'm part of multiple teams, but I'll work with the Xendee team. It will ask you to set a name for the project. In this case, we're working with this hospital. Next, you need to enter the location of the project. In this case, I have the address, but there's different ways in which you can work with this because we're basically linked with Google Maps. So by pulling the information or the name of the location, it will automatically place your site there and also bring information regarding the weather, the tariffs available there that's linked to your specific location. In this case, we'll work with the training lead and create. As you can see, it's pretty straightforward and the platform will kind of like guide you through the different steps that you need to take. So let's start with the electricity use, meaning the loads. So let's go to the building load. Here, as I mentioned earlier, there's different ways in which you can work with this. One is the common usage profiles. So right here, you have different types of buildings that you can choose from, and this will import a load that you can then scale to meet yours. You can also construct it using our load builder. So if we click here, add profiles, here too, you can start from a preloaded shape, let's say the hospital one, but this allows you to edit it. So it's kind of like offers more flexibility. We will assign these to all weekdays and this other one to the weekends. When you hit next, you are able to scale it either by consumption or peak demand. In this case, however, we do have the 8760, so I'll work directly with that. Let me come here and import the load. In this case, we have this electricity load. Hit save. In this model, we'll also work with EVs. So we'll come here, and this is our EV consumption builder, which basically estimates the kilowatt hour per day that you need based on these inputs. So vehicle type, we'll choose a class 4 because we're simulating ambulances for this hospital. We'll say there's 45 ambulances. Charging availability, I want them to charge off business hours, and I want them to be 100% charged. Based on that, we have the kilowatt hour per day. We hit save. Up next are tariffs. And here you can either select a tariff from the catalog. You can also create your own tariff, upload it to your catalog so that it's available to you there. But what we'll use today is our integration with Genability, which basically shows the utility providers that are available at your location and the different tariffs that are available of that specific provider. So in this case, we will work with a time of use tariff that allows us to meet the hospital loads. We hit save. While this charges, we will be working with, well, one thing that I forgot to mention, in some locations, there's certain advantages to using a specific EV tariff for EVs. In this case, we'll use the same one, but know that you're also able to work with different tariffs within one same project. Next are our technologies. So let's start with EV chargers. And this is what I meant when I said catalog driven. So for all of the technologies, you have like several options here listed that you can then filter based on manufacturer, rating, or the place where they are manufactured. In this case, I already know what EV chargers I want to work with. So I'll just use the search engine to bring it up. And as you can see, you have all the available information here, including the spec sheets for each technology that you want to work with. In this case, we'll use the price here, but if you have like another price from your specific provider, you can also input it here manually. There's two ways to work with the technologies. One is optimized, which means to allow Xendee to tell you what is the optimal number of chargers based on the specific load. The other one is to input it manually. In this case, we'll allow Xendee to define that for us. Up next is solar PV. And as you will see in just a minute, it's pretty similar to EV chargers. So you have this exhaustive list of technologies. In this case, we'll work with Q-cells panel. Same as before, you have the information here, the default values. In this case, it asks you if there's any pre-existing panels. We'll say no, because we're starting this project from scratch. This project, we say there has no DRs, and we're working towards adding some. We'll also work with optimized as we did with the EV chargers. And here, same thing with the battery. It will ask you if you allow export. We'll say yes, so that we can leverage that additional income. An interesting feature of solar PV is also that it allows you to restrict the area to make sure you have enough space, for instance, in the roof to install your panels. So I'll kind of select it here. And this will constrain the size of the technology. You can also come back then and edit this, save and close. And finally, for solar installation, you can either upload a file. For instance, if you work with Helioscope, you can insert, you can input the data here. We even have a Helioscope converter tool that allows you to kind of convert the output from Helioscope and make it in the same format that Xendee requires. But if not, you can also leverage our integration with PVWatt, which will automatically bring the solar installation based on your location. We hit save. The last technology we'll work with is battery. So similar process as before, we have the catalog. In this case, we'll work with this specific battery. We'll allow Xendee to tell us how, like, the size of the battery that we need, and we will allow exports. Up next is the financing method. In this case, we only have cash purchase and loan purchase, but as you will see, once we get into design, there's more options, including amortized cost there. For now, this is kind of like a quick feasibility study, so cash purchase will make it. We scroll down, here we can see two incentives. Brief description of it, ITC is investment tax credit, and it basically reduces income taxes for certain DRs. And the rate can be up to 30%, which is the one we have here. These technologies include solar, wind, CHP, battery. So given that we have solar and battery in this project, we'll definitely leverage from ITCs. And then we have makers, which is modified accelerated cost recovery system, which provides immediate tax advantages. So it basically allows businesses to depreciate DRs over a shorter period of time, also offering an incentive for the adoption of DRs. So once we have this set up, as you were able to see, it was pretty fast to kind of set up this project. We'll go ahead and generate a proposal. Here you can get an overview, which is like a shorter version of the proposal. You can get a detailed proposal, which is what we'll do, or you can even customize it by selecting what parts you're interested in, remember that you can then forward this through prospects. So there's might be some things that you want to include and others that you don't. In this case, to kind of show you everything, we'll go with a detailed proposal. I go ahead and click generate proposal. In the meantime, I have one open up here so that we can start going through it. So if you scroll down, you can see the equipment. This is basically the mix of technologies that's recommended together with the size. Here you have some financial metrics, and I'm kind of scrolling down pretty fast because we will then go into design, which has a more detailed reporting. So we'll go into some more detail then, but I still want to show you how with a few clicks, you get kind of like all of this information out of the model. We have the different value streams, the different costs. This is a graph that I like a lot, which basically shows that the bar in the left is what the system was like with no DRs. The one in the right is with DRs. So you can see with just like a couple of DRs and how we reduce that cost from the utility. And we also have them kind of like the lighter blue one here, which are the incentives. As models get more complex, as we will see in design, once we work with CHPs, the savings would probably be even more significant. If we scroll down, we have the cost, well, details about the financing methods, and a very detailed cash flow, both in terms of costs and savings. So let's now come here. Well, while we were speaking, this already generated the proposal, so you can see how fast this all works. But what I wanted to do is show you how to pass from propose to design. It's simply clicking this button here, create, and this will pull everything that we modeled in propose into design. So here you have all of the technologies that we've worked with. The first thing I want to do here is get into the load, show you how the load looks like here. We didn't have this in propose, but you can more clearly see it here. And the other thing that you can do is enter additional loads. So in this case, we'll work also with some cooling load. So we have the cooling load right here. And also some heating load. So water heating, upload file. And you can see what each one of them looks here for each month of the year. We'll hit save. Another interesting thing that you can see here, if we go into the electricity, remember how we pulled in that time of use tariff from Genability. Here you can see what that tariff actually looks like. So we have the different seasons and the different periods. And if you scroll down, you will see this chart, which I find pretty insightful to show you what the different rates are during the different times of the day. We hit save here. Next, we have fuel tab. Here, these are the prices of the different fuels that we'll be working on. As you can see, there's default values here, but if you know of any different values for your specific site, you can always manually enter them here. Save. Another interesting feature of design is the ability to model outages. So you can either model a write-through or curtailment. For curtailment, let me show you. If you come to the load icon again and load management, you're able to define the percentage of the load that you want to curtail as well as the curtailment cost. In this case, we won't model for an outage, but I just wanted to show you that you can do it here. And you can either work with simple, which basically Xendee takes the day with the highest demand of the month and allows you to model for 1 day, 3 day, 2 week outages. Or if you go to the exact dates, you can input that information yourself to define when the outage will take place. Great. So next, financing options. Here, as I mentioned earlier, you have the upfront cash, loan purchase, but also the amortized cost, which is my personal favorite way to model DERs. Multi-year. This is something that's also exclusive to design, and it basically allows you to enter any changes that you see moving forward. So from degradation factors into any increases in site demand, any changes to demand charges, energy charges, and you can either enter like a fixed percentage per year, or you can also customize it and enter a percentage per each year, or even upload files for each specific year. So this can get as specific as it's likely to be, and it's pretty handy in future proofing. Great. Incentives. So here you have some additional incentives. So let's see. Yeah, well, demand response, for instance. For those of you who aren't familiar with this incentive, demand response basically provides financial incentives for participants who reduce electricity during peak demand hours. And for this, you can either manually enter the demand response program, or you can import it from the catalog. So as you can see, there's this is pretty exhaustive list of different demand response programs. And by selecting one, you'll see that it automatically pulls in the information for that program. So that's demand response. Grant funding, similarly, it allows you to add a specific incentive or also import it from the catalog. In this case, for instance, we have Xendee. If you're not familiar with Xendee, the Xendee program provides funds to support the development of a nationwide EV charging network, and it aims to ensure reliable access to EV charging across key corridors. And it can provide, I think it's like 80% of the coverage of DERs. So you can work with Xendee or any other incentives that are grants. LCFS, here participants earn credits by producing, importing, or using low carbon fuels, which can then be sold for additional revenue. Makers, we covered that before. REC. REC basically represents the environmental benefits of generating 1 megawatt-hour of renewable energy, and you can sell RECs to generate additional revenue. And finally, CGIP provides financial incentives for installing DERs, such as solar and fuel cells, battery as well. And it helps reduce the initial capital cost of these energy projects, again, incentivizing the adoption of microgrids. So you can work with all of these incentives here. Another thing we can do in design is work with more technologies. So we will work, given that we now have cooling and heating loads, we will work with a gas generator. In this case, well, there's different ways you can work with this. You can either enter the information of your technology manually. In this case, I'll import from the catalog, and I use a specific generator for this hospital. If you scroll down, you can see the investment and technical specifications. In this case, we'll enable the CHP, the different incentives, and here you have detailed information. We won't get into all of these details today because we want to do an overview, and I also want to show you what multi-node looks like, but know that it can get very, very specific, and you can enter different values here and have a more kind of accurate design to your project. We'll hit save. Up next, we will want to work with cooler and a chiller, given the cooling and heating loads. The kind of most used icons are here under symbols, but Xendee has way more technologies. So if we go to settings, you'll see all of the technologies that are available. In this case, we will enable the heater and the chiller. And by hitting save, you'll see that they are now available here. So let's start with the chiller. Once again, I'll import from the catalog, hit save. Same thing with the heater. I'll import, oh, I brought the wrong heater, the wrong chiller. So we're looking for, no, it was the right one. boiler. There we go. So we'll go with a boiler. And here, yes, I do have the one that I wanted to use, right, saved here. Perfect. So once that's done, we go to main, optimize. And Michael kind of covered some of these before, but there's different things that we can optimize for. We can optimize to reduce cost. We could also optimize to reduce carbon. We could model for resilience if we wanted to work with outages. If you scroll down, you'll see other toggles here. Multi-objective first. So these will basically provide a solution that minimizes cost, one that minimizes carbon, as well as a curve with different solutions that trade off between one and the other. You can also specify time series if you want the dispatch interval data to be an hour, 30 minutes, or 15 minutes. So if you need that level of granularity, you can do that here. And multi-year, in case you entered values in that tab that I showed you before, you can work with multi-year optimization. In this case, we will stick with a cost reduction one. Same as before, I do have a report open up here to speed things up. So same thing as before, you'll see the mix of optimal technologies here. And you'll also see this chart that shows you the cost and emissions compared to that of the reference case. The reference case is the site with no DRs. So you can see how we have savings in both areas. So Rita will cover this in more detail, so I'll just focus on some of the main topics here. One, financial data. This is the graph that I showed you before, but you can see here how the savings are higher, probably given to the work of the CHP. We have some more graphs here and the detailed cash flow. So if you scroll down here, we can see also the benefits of the incentives, which promote the adoption of the DERs. So that's that. So the other interesting graph here is the dispatch. Michael already showed some of these in his examples, but basically the blue lines here is the electricity imported from the utility. The yellow ones is the one from solar panels. The light blue is the one generated by the generator. And then we can see the pink line, which is the state of charge of the battery, and the green one, which is when you use that for self-consumption. So given our time of use tariff, you can see how we leverage the night hours to charge the battery. And during the day, we try to leverage the electricity that was saved in the battery, the one that was generated by the generator, as well as the solar panels. So this is an example of why the load shape matters and how we can kind of play with the different DRs to reduce cost and be more efficient. And you also have the dispatch for heating and cooling. Again, we could explore the reporting for many more minutes, but I want to show you multi-node and what that looks like. So let's get back to the model here. Same as we did before, if we go to settings, we can enable multi-node. What this will do is down here, show more icons. So when you're working with multi-node, as the name indicates, you'll have more than one node. So the first thing you need to do is insert those nodes. So one of them will say it's the feeder. Then let's say we have a node 1 and a node 2. Node 1, node 2. And I'll just do this here to show you how to kind of like work with these technologies, but then we have a project where you'll be able to see it more graphically. So the first thing is to connect the feeder to the utility connection. For that, we'll need a transformer. So we say we want to connect the utility to the feeder, add transformer here. Well, primary voltage, we need to kind of phase that down. So we'll say for 80 kilovolts here. And in this case, you can also import from the catalog You can enter your own information here, or you can allow Xendee to size the transformer, which is what we'll do now. After that, you'll need to connect the feeder to the different nodes, and for that, we'll use cables. So let's say from feeder to node 1, add cable. Similar thing here. You can enter the information, you can import from the catalog, or you can allow Xendee to size it. So we'll do that. One more cable from the feeder to node 2. And another thing that I wanted to mention here is that based on the position, Xendee will say how long the cables are. So it's important to kind of like place these accordingly. And as you can see, you have a lot of flexibility here because this will also impact the losses of your system. So let's jump into these. As you can see, it looks nicer here. So we have the feeder, we have 2 different buildings, and we have the boiler in one of them, the chiller in the other one. So as you can see, we also have these heat and cooling pipes that are important to kind of like put in place. In this case, we have the CHP and the battery connected directly to the feeder. And then we have other technologies such as a solar panel connected directly to that node. So there's, again, a lot you can see from here. If you're a Xendee user, we also have a very detailed tutorial on this. But for now, I wanted to give you this overview of what a multi-node project would look like. And if we go into the reporting of this multi-node, it looks pretty similar to the previous one. So again, if you come to the financial data, you'll see the cost breakdown and as well as the cash flow. If you go to energy balance actually, and you scroll down, you'll be able to see the technology losses of each technology. So this is kind of like interesting, especially when working with multi-node. If we go to balance of system, you have a bill of materials of the different cables and transformers. And if you go to dispatch, this is kind of like a unique feature of multi-node, which is the ability to see the dispatch at a nodal level. So this is kind of like the aggregated view. But as you can see here, you can look at each specific node, and that will allow you to have a better understanding of how the system works. Same thing for heating and for cooling. And we also have the power flow. Similar logic here. You can see the power flow for all nodes integrated, but you can also see these at a nodal level. So there's a lot of valuable information in these graphs right here. And lastly, I wanted to show you the one-line diagram that you can get from Xendee. So if we create one-line diagram, you will see how it loads pretty fast. I think I have one open here, but it's still, yeah. So let's work with this. This is the one-line diagram of the system, and it allows you to check the power flow factor of the system, confirm the power rating of the different cables and equipment, as well as check that the voltages remain within the necessary standards.